Hi students, Jordan here and welcome back to Bio 25 Online. In today's video we'll be covering Lab 16 in your lab manuals, which is actually the membrane potential lab, more commonly referred to as the bean lab. Now because we can't be together in person, I've had to modify this lab activity quite a bit, so I ask that you are patient with me throughout this process. In the upcoming video there are a couple times where I'll actually ask you to pause and either read something or go to your Canvas page and watch a separate video. And I hope you can be patient with that as well. Without further ado, let's get into the video. Today we will be covering Lab 16, which is the membrane potential lab, also more commonly referred to as the bean lab. Now because we are not together in person, I have had to make some modifications to this lab activity, so I'll appreciate your patience as we go through this presentation, and as always, if you have any questions, feel free to reach out. So today we will be working out of pages 84 and 85 in your lab manual. First of all, we have some definitions that we need to go through before we can get started. Let's start with the word ion. What is an ion? An ion is an atom or molecule that has a net electrical charge. There are two types of ions that we care about today, cations and anions. A cation is a positively charged ion, and an anion is a negatively charged ion. How I like to remember the difference between cations and anions are cats make me happy, and happiness is a positive thing, and cations have a positive charge. So there you go. Next, let's talk about simple diffusion. Simple diffusion, if you'll recall from our osmosis lab, is the process by which solutes are moved along a concentration gradient in a solution or across a semi-permeable membrane. So now let's talk about concentration gradients. A concentration gradient occurs when a solute is more concentrated in one area than another. Finally, we need to understand the difference between depolarization and hyperpolarization. So depolarization is a change within a cell during which the cell undergoes a shift in electric charge distribution, resulting in a less negative charge inside the cell. And hyperpolarization is just the opposite of that. So hyperpolarization is a change in a cell's membrane potential that makes it more negative, not less negative. So to continue with the content on page 84, there are a couple questions that the lab manual wants you to answer. The first question is, which ions are the predominant ions of the extracellular fluid? And the answer to that is sodium chloride, or NaCl. The next question is, which ions are the predominant ions of the intracellular fluid? And the answer to that is potassium, which is also abbreviated with a K. So now I would like you to all pause the video and really quickly read the electricity review on page 85 of your lab manual. And then when you're finished doing that, feel free to press play and continue on with the video. Okay, so I can't actually get this video to play within my presentation. However, this video is on membrane potentials, and it serves as a substitution for the lab activity you would have done were we in class together. So at this time, I'd like to ask that you pause my YouTube video, go to your Canvas page, find your Week 10 module, and watch Lab 16 video number 1, and then come back here when you finish. So this next video is on the sodium-potassium pump, which is something really important that I would like you to all understand by the end of class. Again, this video will not play within my presentation, so at this time I'd like you to pause my video, head back to Canvas, and watch Lab 16 video number 2. And then when you're done, come back to this video and we'll kind of wrap up this presentation and talk about what I would expect you to know. Alright, so hopefully those videos helped you understand the processes that we cover in Lab 16 a little bit more in depth. But you're all probably wondering, what do I need to know from this lab? So I've made this slide here outlining what you need to know. So I would really like it if you knew what are the two forces acting on ions. Additionally, it would be awesome if you could determine which direction a specific ion, for example potassium, would move due to an electrical gradient. Next, the membrane is impermeable to all ions unless a transport protein for an ion is placed in the membrane. So in a world where a leak channel is placed in the membrane, it would be cool if you guys could determine how leaking ion exchange affects the electrical charge on the inside of the cell and the outside of the cell. Next, I really want you to know about the sodium-potassium pump and what exactly it does during each cycle. Finally, big picture wise, nerve cells are signaling cells, and I would really like it if you could understand the function that different ions have in signaling. So that's all I have for you guys. If you want to actually try to go through Lab 16 on your own using a whiteboard and just drawing out the different molecules, I would definitely encourage you to do so. I think that would definitely be to your benefit to actually go through the lab and try to figure it out. And as always, if you have any questions, any comments, any concerns, you know how to reach me. I'm available via email and phone call. Also, I'm holding office hours this week, and see Canvas for more details on that. Finally, for our fun anatomy fact of the day, when you're in love, the brain releases the same cocktail of neurotransmitters and hormones that are released by amphetamines, which leads to increased heart rate, loss of appetite and sleep, and an intense feeling of excitement. So really, love's just fake, and it's chemicals in your brain trying to get you to all go reproduce. Okay, so hopefully that lab activity helped you all understand membrane potentials and the sodium-potassium pump a little bit more in depth. If you guys have any questions, you know where to find me, you know how to reach me, I am here for you. And without further ado, I'd just like to remind you to stay safe, stay kind, and stay healthy. I'll see you in the next one.